Hi, and welcome back. Just a short bit of numerology today, just for fun. We're going to look at this crazy loop that starts at 529, hits a bunch of huge numbers, and then comes back to 529, looping around and never reaching 1. But let's go back to the start. So if we imagine any old 3n+1 loop like this, up, 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 down, up, then all the way back down, there's only one number that obeys the 3n+1 rule and returns to itself this way. Usually it's some fraction instead of a whole number. If it's a whole number, then it's a counterexample to the 3n+1 conjecture. And we previously looked at a special class of loops, the circuits, ones of length k that go up, x times, and then down, k minus x times. And the bottom member of this kind of loop is always 3 to the x minus 2 to the x over 2 to the k minus 3 to the x. And we found that this can never be an integer for any x and k greater than 2. Now, if x and k have a common factor, the proof is easy. But if x and k are co-prime, the proof is way hard. And a long time ago, I had a strategy, which was to try to prove if x and k are co-prime, then these two things are also co-prime, so this can't divide that. And after working on that for a while, I found that once in a blue moon, these two things are actually not co-prime, like this case, where they both have a factor of 331. And it turned out that only certain numbers can be shared factors, and we called those Kershaw primes, and they're really few and far between. Anyway, this crazy fraction is the bottom member of a certain 41 length circuit, and if we put it through the 3n+1 rule, we can get the next member of the circuit, which is this. Now, the same 8th grade math gets us from 529 to 3,321,787,921 if we apply this rule instead of the 3n+1 rule. So, coming back to the loop from the beginning of this video, this isn't a loop under the 3n+1 rule, it's a loop under the 3n plus 6,643,574,255 rule. That is, if you've got an even number, cut it in half. If you've got an odd number, multiply it by 3 and add 6 billion something, and then divide by 2. So, this is another crazy loop. I mean, what are the odds that 529 is going to hit one of the super rare numbers that if you repeatedly divide it by 2, you get back exactly to 529. Well, it'd be weird if some number looped back on itself under the 3n+1 rule, but weird things happen. Okay, see you next time.